Hello everyone, a very good afternoon. I would like to thank you all for joining us today. My name is Aparna Haldar and I'll be hosting this webinar. Before we get started, please let me take a few minutes to introduce Payatu. Payatu is a research-powered cybersecurity consulting firm. We have a decade-long track record with a singular focus on cybersecurity. The foundation of Payatu rests upon three pillars: community and conferences, consulting and training, products. Community and conferences encompass NullCon, an international security conference, training, and exhibition platform. Hardware.io, a hardware security focused conference along with other initiatives. Consulting and training focuses on thorough security assessments, which helps businesses to discover security threats and further provide training to strengthen network infrastructure. Lastly, we have two products in private beta trials, that is Exploity, a firmware analysis framework, and CloudFuzz, an advanced fuzzing framework. Here is an overview of the various consulting assessments we are known for across the globe. Payatu has delivered many cyber talks and workshops in top security conferences that also include Black Hat and DEF CON. We take pride in the decade-long impact we have created by contributing to the cybersecurity community all around the world. That was all about Payatu. Today, Kartheek Lade, Payatu's associate IoT security researcher, will deliver a webinar on automotive security. You can read about him on this slide. Before I hand it over to Kartheek, I request you to follow a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We'll answer the questions during the intervals or at the end of the webinar. We will be releasing the recording of this webinar on our LinkedIn page, so make sure you are following Payatu. If you are not following the page, check the link in the chat box. You will be directed towards Payatu's LinkedIn page. Without further ado, let's get started. Kartheek, over to you.
Thank you, Aparna. Hi, guys. I hope you're all safe and safety. So let me share my screen. And do tell me if I'm audible and you can see my screen. Can you put in the chat, anyone, if you can see my screen?
Yes, Kartheek, your screen is visible as well as you're audible.
Okay. Hello, guys. Very good evening. So I welcome you all to Introduction to Automotive Security from an attacker's point of view. And a quick acknowledgement I would like to give is some of the images used in this webinar are not owned by myself. Credit goes to owners. It might be from some research papers which my colleagues are doing or from reports which I have taken. So if you find any, make sure that the credit goes to owner. I'm not claiming anything to that. And all the views and opinions are from my learnings in my experience, and I excuse if there is any miscommunication of information. And also these 3 points, please keep in mind overall the webinar, this is we are mind setting. So when we are looking in vehicle networks, there's not only CAN bus, there's a lot of protocols, but to constrain ourselves to get more knowledge, we are discussing about CAN bus in this webinar. And also think like an attacker. Let's all think like an attacker. We can be from different backgrounds. We can be from managerial backgrounds, software backgrounds, anything. But let's think like an attacker to assess more about, to know more about what is automotive security basically. And the question which always comes is my vehicle a computer? So if you think your vehicle is a computer, please put in a chart and why you think your vehicle is a computer. We are going to, discuss more in detail. A little bit of myself. So I'm an associate IoT security researcher at Payatu. So right now I'm focusing more on ISO 21434, how it helps automotive security and wireless security assessments. And I contribute and allowed to contribute more on open source communities and engagement activities. So I always help people who wants to get started in InfoSec. I've been a speaker at conferences like Black Hat, Cocoon, BZ Delhi, and many other community chapters. And I also create blogs and open source tools to learn more about automotive security so that like-minded people can get and learn more. So let's get into the technicals. So first thing, when we are talking about an autonomous vehicle, what do we mean is it is capable of fulfilling the operational functions of a traditional vehicle without a human operator. So something you think like, you just give a GPS point and it can drive you through that point, or you can use automated navigation functions and everything. So when we talk about a connected vehicle, it is not autonomous vehicle. It is just that it can download secure updates. It can have Bluetooth functionalities and GPS functionalities inbuilt. So that is a connected vehicle. So most vehicles with vehicle to infrastructure capabilities are connected vehicles. What is vehicle to infrastructure? We'll talk in this webinar. And what do we by CAV? Connected autonomous vehicle. Both autonomous vehicle and connected vehicle. Example, clean example is Tesla. When you see a Tesla which has automated driving, that is a connected and autonomous vehicle which has sensors and everything. So a little bit of definitions. So when we say CAN, that is controller area network. We will learn more about this protocol in coming slides. And when we say CAN bus, it's a twisted pair of wiring where CAN message floats. So think of it's like a river where a CAN message like both floats. Okay, ECU, electronical control unit, and it's an embedded component. Central gateway, CCW. We will talk what is central gateway and everything. Telematics control unit is known as TCU, and OEM. This is one of the important things. Original equipment manufacturer. Who manufactured that equipment? You might see in many things, but it can be in different products. But who first manufactured that product? Who is the one who from scratch manufactured that product? So that will be called as OEM. And the big question, this is from a famous series called Blacklist on Netflix. Blacklist. I think I don't remember the episode and all, but I am very fond of this thing because I immediately related to the series. They show real car hacking in that. They don't show. You get an example. So a person, very important person dies. So and the forensic analyst says, like, if I can look at the car, I might confirm whether it's electronic manipulated. So the question we have is, can we actually hack into a car? There are many people. I don't know whether you're from which background, but is it possible? Yes, it is possible only because cars are no longer mechanical components. They are advanced embedded devices working together with more than 100 million lines of code operating in a centralized fashion. So the key points here is like embedded devices, centralized fashion or centralized network, and more than 100 million lines of code. In comparison, you can say a Boeing 747 has around 20 million lines of code. That's the biggest airplane for passenger-based airplane. So I'm talking about one car compared to a Boeing 747 has more than 100 million lines of code. So two concepts which we should make very clear: what is safety, what is security. So safety or functional safety, it's what guarantees the physical integrity of a driver, passengers, or road users. Something like brake assist, sudden brakes if it detects something in the vicinity, anti-lock braking system, collision warning if there is any obstacle in your way through the LiDAR sensors or IR sensors, whatever it is. So security refers to the protection level where you cannot think that this kind of threat might happen. So radar sensor detecting a passenger or a body or entity in its range and giving a collision warning is programmed and developed in a way that it will assess this kind of situation. But when you talk about security components, you won't know what kind of things happen. You can never imagine how an attacker or an adversary can be doing it. But if we talk on a product level, a good quality product is the one where both safety and security are well maintained. Okay. So, and one more important thing, safety cannot go with security and security cannot go without safety. Both of them are very important for the quality of product. So I know many of people who might have traveled in cars, almost most of them, 99% of us might have traveled in a car. And then we have seen what do you mean by car is like a traditional vehicle in previous years, a decade ago or something like that. So what is a modern vehicle? So when I say a modern vehicle from an attacker's point of view, it's not just a powerful motor vehicle. It has a wireless networks, apps, electronic components, sensors, actuators, and driven by the software with so much connectivity, such as vehicle to vehicles and vehicle to infrastructure, vehicle to anything. So vehicle to vehicle example, a classic example would be smart city vehicle grid, where if one vehicle, you know, detects a bump on a road or any obstacle, which any accident in the road, so it can share the same information with the vehicles of same model or the same company or maintained by the same backend solutions to the other vehicles in the vicinity. So that would be vehicle to vehicle communication and vehicle to infrastructure. So a lot of electric scooters nowadays, and electric vehicles, now they can download softwares, not only electric diesel vehicles also, they can download softwares from backend servers and all. That is vehicle to infrastructure from the OEM's infrastructure. So we remember OEM definition. OEM's infrastructure, if they have any secure updates, if they're giving it back. Vehicle to anything, it can be traffic lights. It is the futuristic way, V2X, traffic lights, smart meters, backend for downloading updates, and Tesla always, every mile it goes, every Tesla vehicle, it will send the data back to the company. So that comes under V2X and maybe V2I also, depending upon. In case of Tesla, it's V2X. So in a general, car contains more than 100 ECUs manufactured and developed by different OEM vendors. And these OEMs co-develop it along with the Tier 1 and Tier 2 providers for them. So imagine Tier 1 and Tier 2 or something like Tier 1 are the ones who design the PCB, and Tier 2s are the ones who design the chips, microcontrollers, processor, memory chips, and everything. So the whole network is very closely knitted so that each company will have a lot of sources and multiple vendors for one particular car. So a classic definition, when you say automotive security, please remember it's not just equal to physically hacking a car for physically hacking a canvas. So automotive, it's a very, very little crispy part. It is very important and very crispy part. But while thinking like an attacker or an adversary, targeting a connected vehicle, we are going to talk about connected vehicle in this whole session. So we have to target the entire ecosystem of the vehicle, which contains both how it is communicating with outside entities and how in-vehicle network is working. So Karthik, what is Canvas? Now you gave us a new term. So Canvas is a protocol. It works in both physical or object and transfer layer of the OSM model for a reference. Okay, Canvas has differential signaling, and it is very well used by ECUs to communicate with each other. So if we can, let me zoom in. So if you see here, you see a lot of bunch of zeros and ones. So in general logic, if it is up, then we consider it as one, and if it is down somewhere here, we consider it as zero. Where's the laser? One second. Okay. So, but in Canvas, it has a differential signaling and an inverted logic. So what happens is there's two wires, CAN high and CAN low, in every canvas of the ECUs. And when there's a differential voltage, like voltage is different between CAN high and CAN low, there's more than 2.5 volts of difference between the high and low, then it is considered as a zero, and which is a dominant. So other ECUs in the network cannot bring down a dominant state to a recessive state, where the voltage difference is zero, that will become into recessive state. And how it is helping, I'll tell you. So it has built-in error detection and fault confinement also. So in transfer layer, it has fault confinement, and it'll always check, every ECU will be checking what it is going on, how the message, exact messages in bits, whether it's identifying or not. So if we see how this differential signaling and so let me show you once again. So if we see, there's an arbitration field which is ID, and there's a data field. For now, let's focus on arbitration field and data field. So what makes Canvas so important, not just differential signaling, but NCDA, non-destructive collision avoidance, is what makes Canvas perfect to work in a centralized network of in-vehicle communication between ECUs. Think about it, centralized communication in vehicle, not external. So what exactly is non-destructive collision avoidance? Let's say there are two ECUs which are trying to transmit the data, what is collected according to their functionality. And one ECU is having an ID of 134, and one ECU is having an ID of 144. So when they both transmit, because of the differential signaling and without noises and arbitration ID, and NDCA basically picks up the most prioritized ID. So if we break it down, let's consider this as arbitration IDs. So when node 0 is transferring and node 2 is transferring, both will be able to put it into the bus, but both the nodes at the same time. In previous slide, we discussed both will be looking for fault identification. So they will also constantly seeing the value on the bus common. So We are now thinking about two buses, two nodes, but think about in like 30 or 40 issues are trying to communicate at the same time. So the one with the least ID, when it sends the dominant value at the end, so that will be winning the bus and it will be taking over the bus. So how it is going to help? See, the 134 will be taking over the bus. How it is going to help the bus? It helps in priority based message delivery. So imagine 134 is being assigned to a brake and 144 is being assigned to a indication lamp. Before giving an indication lamp in logical base, you should always make sure that your brakes are getting applied. So there the CAN bus helps. And one big problem is CAN is not built keeping security as an important factor. So that is why there are a lot of protocol level attacks like replay attacks and node spoofing can be happen since it's a centralized fashion. So whatever message you are going to keep, there are no hash checks. There is no confirmation messages and all like a TCP thing. It just takes up it and acts according to it, acts according to the how the issues are thing. So in an example base, if the vehicle is applying brakes through CAN messages, if you send the same CAN packets by recording them, so you will be also able to apply the brakes without the issues acting on itself. And yeah, obviously there are data limitations. If we see in CAN packet, in one CAN packet, you cannot send more than 8 bytes. So that is one thing. So because of these kind of limitations and all these things, many other protocols on based on CAN also been developed. CAN open for industrial networks and all industrial manufacturing networks. CAN FT, where you chain multiple CAN packets to deliver a larger payload. 8 bytes is not sufficient enough, believe me. So yeah, and basically CAN bus itself has this kind of attacks. So we are slowly looking towards what is the whole attack surface. So, and the second thing, ECUs, we are talking about CAN bus, ECUs use CAN bus and all. What is an ECU? ECU is basically an embedded system in vehicle used for in vehicle communications and responsible for controlling specific functions. So imagine an ECU as a small constrained application where it is only accepting inputs from certain thing and behaving according to that certain things. So they are very much capable of handling multiple actuators and according to the input. And these are custom made by OEMs for car companies and to fit in their architecture, how what protocols they're using. They can use CAN FT, but the ECUs also need to support, right? So what protocols they're using, what company, and what is the functionality, what is the hardening level they are using in securing the TCUs and all. So it is extremely safe. At least it should be extremely safe. But in reality, it's not extremely safe. There are a lot of side channel analysis and glitch attacks can happen on ECUs. And in previous 1-2 years, also these kind of attacks and CVEs have been assigned for glitch attacks and side channels on ECUs. Because the problem is we already saw OEMs will pick it from tier 1 and tier 2. So if you find a particular vulnerability in particular chipset of a microcontroller or a processor, so whoever is using that microcontroller processor, they're all getting affected. So this is one of the main points where automotive security can break. Structure of automotive security can break. And there's OBD2. OBD2, you can say it as like, diagnostic point of your whole vehicle. You generally find it under your steering wheel or under the driver's seat. But what basically OBD2 is like, it refers to the vehicle self-diagnostic. So we saw CAN bus and how ECUs use CAN bus. So who will make sure that all these issues are working in a correct fashion? So that is where UDS come, Unified Diagnostic Services. So UDS services can be implemented in ECUs. Obviously, you have to make it in that way. And then you can check what is the trouble code, whether it is working or not, whether it is able to take all these inputs or not. There are different DTC diagnostic trouble codes in for this. So I have attached a link also. Once you get the PDF version of this presentation, you can refer it to that. So if the standard is Society of Automotive Engineers J1979, it defines what is the IDs. So one of the main functionalities is like, it can give you real-time data, and also it will allow you to reset an ECU or sometimes erase an ECU. So there is security, inbuilt security of UDS, but it depends upon how the manufacturers and OEMs are implementing that security. So if we see a sample ECU network, and I regret to saying it's a sample ECU network because it is at least 6 to 8 years old. Modern vehicle ECU networks we won't be able to see unless we are a client for them doing the penetration testing. So in my experience, they will only give it to the clients so that they don't want it to get out. So it is very hard also to map all these things just by picking up a car and all. So there is OBD2 port for diagnostic, and it is controlled connected to every ECU, and it is being controlled by vendor-based or OEM-based tools, which they self-made so that they can use some authentications and everything to confirm whether they can go and erase the ECU or not. And there's a body control module which can control steering lights or indication lights or headlamps and the windows and all these things. And you see a lot of ECUs for dedicated for their purposes: engine control module, anti-lock braking system, power steering, and parking sensors, airbag control module, and audio control module, HVAC, and everything, instrument custom panel. So dedicated ECUs using CAN bus messages to communicate with each other in a centralized communication or centralized network, and using UDS protocol, Unified Diagnostic Services Protocol, for fault checking and all these things. So is there any tools available for physical car hacking? Yes, there are a lot of tools, but these are the something which I personally use. I use exploitative framework for checking the messages and tapping the bus, and CAN utils, which is an open source framework for sniffing and dumping a lot of traffic by different buses. Convert, even there are 2-3 buses which I'm connected, I can collect all of them at the same time. And this Python CAN library which I use to write my own custom scripts for a particular specific task. And there is Canalize, which I created for filtering messages and all. And hardware, commercial hardware, there's CAN Pico, which gives you more handling on what exactly you can send, what particular message you will be able to send and all. And there's USB tin for it's next based. It uses CAN utils. You can use CAN utils to interact with the next based USB tin. So that is there. And now we saw CAN bus, we saw ECUs, we saw UDS, different tools available. So we also know that automotive security and physical car hacking are two different things. So what exactly is automotive security as a whole then? So when we say automotive security of a modern vehicle and modern implementations such as TCU for vehicle communication, like telematics control unit to download, update data and software, that also should be considered. Infotainment hub, there's large screens popping out in Tesla and a lot of vehicles where you can control music and do navigations. And in electric vehicles such as Ether and Ola also, they have this dashboards where you can control things. That is considered as head unit or infotainment hub. Generally, these will be HMIs, human interface, human machine interfaces. So when they have Bluetooth, we have to consider Bluetooth for checking. Also, we have to consider GPS, radio for tire pressure monitoring systems, or passive keyless entry. Sometimes in these modern vehicles, you see, you just touch or open that door handle a little bit. If the key fob is or the key is in the vicinity of that radio, then you can unlock the vehicles. That also we have to assess. And there are LiDAR or radar sensors in case of autonomous vehicles. We have to assess that also. And not only this, nowadays what happening is, like, because of this centralized fashion of CAN network and all, if any functionality is depending on CAN, then you can make a third-party service, software or hardware, seat warmers or remote starters and all. There's ADAS, advanced driver assistance, and AI or cloud services for the same. So we have to consider that also in the attack surface. So in a fancy way, if we put whatever is in the white is in vehicle, and there is, you can always tap the OBD2 port, and attacker can tap it, or he can attack on in-vehicle infotainment or the head unit, or attack the Bluetooth and attack your check if they can change any updates or something through USB. In a very recent Mercedes bench by Skyco research team, 2 years ago in 2019, they were able to update it through USB also software, and that is one particular point. And when I say there is Bluetooth, we have to assess it. It doesn't mean that there's Bluetooth so we can hack it. What I mean is, we have to check what functionalities are being implemented using Bluetooth, what functionalities are being controlled using Bluetooth. Any non-authenticated user can do the same thing, or if only authenticated user, how well the security mechanism to authenticate a particular user is happening. So we have to think about all of these things. So when we say about remote start or APIs being used as software inside the in-vehicle info system, can we attack the cloud backend servers? What happens if someone can control the backend? Most vehicles, they have a remote command also, so they can shut down the vehicles from backend. They can switch on indicators, control steering from backend and all. So this is possible. This is right now in network. I'm not talking about 2 years or 3 years in the future. I'm not talking 2-3 years backend. I'm talking about today. All of this is what making our car electric vehicle, it can be electric vehicle, it can be diesel vehicle, whatever vehicle it is, modern vehicle, it is what happening in 2022. So if we see in a hierarchy level, so when we talk about all this modern vehicle, the basic, so we see the battery management system, if it's an electric vehicle, and the memory where the information is getting stored, or the embedded components memory, and hardware interfaces, what are all the interfaces which are allowed, USB ports, some debugging ports on ECUs, electronic components, IoT based, JTAG ports, UART ports, and all. What is the operating system? Is it Windows? Is it Linux based? Is it Android Auto? Or it is Autosar? What exactly it is? And what are the firmwares being run on those embedded components? What is the diagnostics capability of that vehicle for a non-authenticated user? What is the softwares being used in that infotainment or HMIs or in telematics? And what is the communication channels available for that vehicle? So this is what makes the entire attack surface of a modern vehicle. Okay, we have seen all these fancy terms. There's Bluetooth, there's Wi-Fi. Can anyone can do it? All these things. Is it really possible? It is possible, and people have already done it. While reading these things, just don't think like it's a single click. It might be a single click exploit, but there's years of research and scrutinizing each and every component of work has been done. So it all started with Jeep. Media got more and more attention. Automotive security got more and more attention to what hackers were attacking vehicles. So automotive industries are now doing their all these assessments and all. So Jeep hackers, Charlie and Chris Walsack, they were able to hack into a Jeep through a telecommunication service, and they were able to control a lot of functions. And in very recently in 2020, there's this T-bone attack. So I'll show you, zoom it. So using a Wi-Fi of Tesla service, when it is getting charged, it search for particular SSID. So using that, you can attack into it. And the research papers are already there, T-board research papers on the internet, but it is very much redacted because, sorry, companies won't be allowing their vulnerabilities to be exposed like outside. So if it is a web-based vulnerability, it's a server-based vulnerability, you get assigned a CV. In automotive industries also from last years, you get assigned a CV, but it depends upon where. If they can fix it, they will immediately fix it. And the problem is, in automotive, a car will take at least 3 to 5 years of development life cycle. So it is very hard. The car you're seeing on road, it at least been designed, the design has started at least 2-3 years ago, minimum of 3 years. So sourcing components, manufacturing, assembly line, and checking software development, and binding all together and making it. There might be some mistakes, or there might be some misconfigurations, or new attacks will be getting developed every day. New attacks are getting rise. So all these things. So if you're thinking this is only happening in US and UK and all, no, it's not only happening in US and UK. It is happening in India also. So in India itself, there are more than 4,100 vehicles were stolen in Gurgaon using RF-based keyless authentication. And in European Union, the Tier 1s got affected. So their chips, whatever the components they are using, all the ECs which are using them are getting affected. OEMs were affected, backend servers of them are being controlled so that they can get control to vehicles which are being generated, or which OEM parts were being used in the vehicles. And Europe's vehicle to grid communication was affected. That would be like something like a charging station grid. So they were able to, even in recent Russian and Ukraine conflict, we were able to see messages in Russian electronic charging things. They were displaying some discriminating messages against Russian ruler Vladimir Putin. So all these things we might not think. So an attacker would think, what is the impact I can make to a vehicle? A developer will think, what is the functionalities being impacted? A managerial level board meeting or something, they will think how it is affecting the financial or privacy of the customers. A customer will think, will I die? As the first slide we see, is it possible? Is it in a threat level is that high that I'll be dying? So different people in this chain have different opinions and different concerns. So who's are functional safety engineers, they have different concerns. Cybersecurity engineers, they have different concerns. So how are we going to do it? So how everyone is getting safe, that assumption that, okay, I am safe now. So overall map, if we see look at a whole secure vehicle, then we'll be having secure OTA updates. And what will mean a secure vehicle and secure OTA updates. So if you have a vulnerability, if you are able to patch it through remotely, then you can have secure OTA updates through TCU so that it can safeguard the vehicle from software side if it can be fixed. Otherwise, if it needs to be changed through physical updates, if think of it something like an particular attack in that particular version of firmware being run in this particular OEM made ECU, then can you do the physical update? If yes, how are you going to do it? If you're just doing it through JTAG or something and stability protocol and leaving that port open after that, then it opens something, a window or a door to attacker to access that particular protocol debugging capabilities and then dumping the firmware and reverse engineering it back. And the opportunities are like vast. And protected in vehicle and external communications. CAN bus is not protected. So we have to agree. And it is very well implemented and very functional safety wise, it's very well implemented, but security wise, it's not protected. And external communications, how it is being communicated, like the T-bone attack, for example, we see the external communications are compromised. In Jeep attack, the external communications are compromised. And in Tier 1s are getting affected and OEMs are getting affected in European countries. Their external vehicle communications are getting affected. And hardware security of embedded components, the same thing, which use of physical updates. Can anyone dump the firmware of ECUs or any other HMI machines used in the vehicle? Can anyone tamper those devices? Can anyone debug, collect logs, and change information? Or like, when it is doing some crypto checks, password checks, and calculating keys, is there anything like that? So there's in this particular research paper 4 or 5 years ago I was reading. Since they are using the same compiler, the same C code is generating same random keys multiple times when it is supposed to create a different random generators. So all these things, whatever is happening, that comes under software. So that is what security of different softwares and apps used inside the vehicle. Not software, firmware. So what do you mean by software is like if there is a particular vulnerability in that Windows version or Linux version or AutoServe version, Windows CE, whatever it is, if that is there, then how we are going to fix it, how it is going to affect. So in apps, can the vehicle infotainment get body control mod access to body control model to control doors and all? So if we can reverse engineer the app and get the API keys or access to the backend servers, because there is some other vulnerability in the software used in the backend servers, then can in a way it is allowing us to get into the backend servers through the use the third-party services or apps being used in the vehicles. We can go into the vehicle and generate things and all. So one typical example for that is like in Ponto 1 2019, I believe, a Tesla was able to, there was an XSS in the Chrome version used in that particular Tesla. So they were able to pop a shell into that infotainment hub where they can control several functions which are disconnected to the infotainment hub. So a lot of things. So all this comes into this overall map when we talk about whole securing a whole lot of modern vehicles. And OBD2, through OBD2, since it's supposed to be connected with all the components inside for UDS capabilities and data dumping, it should be going to a central gateway where one-side communication is allowed or authenticate-based communication is allowed and all. So now we got this thing. It's very packed. A lot of players, a lot of positions we have to take, and a lot of softwares to be checked. There's VAPT, there's web assessment, there's AppSec, there's cloud infrastructure, there's hardware, and everything of its own vertical has advanced attacks and all. So the question now would be shifting, is my car a computer, to how is securing the whole ecosystem possible? So apart from this, in automotive, specific to the automotive, there is two more major concerns. That is developers versus security. Anywhere it will be there, but in automotive, there's functional safety guys versus cybersecurity engineers, and how they're developing, what are the aims. As we discussed, different people, developers will be thinking like, what is the functionality being affected? Security people are thinking like, what is the impact I can create? And manager level people are thinking like, what is the privacy or financial or the safety of the people are getting to. So all these different opinions while developing the vehicle together, it creates a lot of disturbances, and sometimes miscommunication happens because of that. There's a lot of things. One classic example for that thing would be Jeep attack. In Jeep attack, what happened is the chip which is controlling the CAN bus, which can control, it is not controlling, which can control the CAN bus, which can tap into the CAN bus and the infotainment hub. These two have an ITC line. I'm very sorry, it's not an ITC line, it's an SPI line. So this line was not being used, but it is there. So when it is not being used, there's no pointing of keeping it. So these kind of hiccups will allow us to attack. And how can I evaluate? There's a lot of point of views and all. And the challenges in particular automotive field is like 3 years of development development life cycle, multiple OEMs, tier ones, tier twos, and all. And there's a shared responsibility between suppliers. Supplier cannot say like, okay, even though it is the attack, even it is in the product or the microchip I manufactured or the microcontroller I manufactured, I'm not going to take responsibility because I don't know where and what kind of functionalities you are implementing on top of that. So consider two vendors of the same company saying like one guy is just using it for a non-critical safety component and other guy is using it in a vehicle, where if you can control that particular in and outputs of that chip, you can control the functionality of the vehicle. So immediately the threat level gets escalated. So that is one thing which we have to keep in mind. And how are we going to do it? So this is where ISO SAE 21434 code vehicle cybersecurity standard comes in place, where it thinks not only about security or not only about safety, thinks both about safety and security, and it gives a lot of information and importance given to organizational culture of cybersecurity, project cybersecurity culture, and what is the supply chain, where it is getting components, do they have adequate measures to take care of attacks, and also it provides a method to evaluate threat analysis and risk assessment. So how do you do that? And if we see the table, so first in 5, there's an organizational cybersecurity, 5th chapter, and the next chapter would be project level cybersecurity at the project level. And additional to safety, obviously every vehicle has to get done functional safety testing first. After that, they will be doing security testing. There'll be vulnerability analysis, cybersecurity and management, and vulnerability management if something happens after assessment, and cybersecurity cycle for things post production. All these things will be happening. So, sorry. So even the design is generated after this cybersecurity and all this kept in mind. So we have to evaluate the risk. So there cannot be any device which is 100% secure. So always we all live with risks when it comes to the electronic components which we use in our daily life. So how to evaluate that? How can we say? See, some companies might think, okay, I'll pick up these kind of strict measures to, I don't care about my marketplace, but I want to take care of my security and safety of my passengers or vendors using my components. So some companies views will be like that, but some other companies will be having a different views of getting the first marketplace or making a product more affordable and all. So because of this, the standards has been United Nations Cybersecurity Regulation comes into force from Jan 2021. That's last year. It is in force. And from August 2021, SIE released the final draft of 21434. Previously, it used to be a secondary draft, primary draft, and all these drafts, which is subjected to changes and all. But in August 2021, it's mandatory and they released it. And European Union also mandates cybersecurity for all vehicle types from this July 2022. You have to follow these things. And after July 2024, cybersecurity is mandated for first registrations. Even though you register that you're going to make this vehicle, you're going to register your vehicle, you have to get this done. You have to follow the standards. Not only 21434, there is European Union WP 1R155 cybersecurity through entire life cycle and software updating R156. So all the standards you have to follow. And coming to the point where how this TARA, how 21434 is giving a common TARA parameters, that analysis and risk assessment parameters for me. So in 21434, there are cybersecurity assurance levels. If your assurance level is 1, that is you don't have much confidence on the vehicle or the component getting secured and the functionality or the impact it is affecting. And if it is cybersecurity assurance level 4, then you can go in confidence that, okay, this is very hard. It is very hard to do it, but it is possible. Nowhere, as 21434 says, like it is cannot be possible. You cannot hack it because we set these parameters, you follow this. It is possible, but it is very hard to do it. Multiple experts or things and all required. And yeah, any particular damage scenario will be having 4 functionalities according to 21434: safety, financial impact, operational impact, and privacy. So consider an example like spoofing headlights through canvas. So it can impact safety in a medium way. It is not impacting the financials of any component company because they don't need to replace it, because the can message itself is basically, susceptible to spoofing injections and replay attacks. But if it is a particular attacker were able to bypass the central gateway and then put the message, then they have to take it. Then what is the financial impact impact is going to think, and the operational impact. So just spoofing a particular indicator light or this doesn't matter. It doesn't make sure that you cannot use the vehicle afterwards. But if you jam the entire vehicle and the ECUs are not programmed in a way to handle that particular thing through first testing, and it damages the operations of functionalities of the ECUs, and they cannot function in a safe way, then the operational way comes. And privacy, can any personally identified information (PIIs) can be extracted because of such attacks? Maybe attacks on infotainment, attacks on other TCUs. Can any private information or IP based in intellectual property can be obtained? Then that comes. So based on this, you will be rating its impact, and there's an attack feasibility. How much time it will take, what is the skill of that attacker, what are the tools he requires, what is the knowledge he requires for this thing. And all this has been given to 1434 on evaluating based on the comparison between the impact it creates and the feasibility of the attack. Based on different parameters, the cybersecurity assurance levels will be generated. So companies will now then put it in their ISO report that this is the assurance levels of our components, of each component in the whole network. As a whole, we are looking at this, and we have to keep in one thing in mind. 21434 never talks about, or it won't talk. Basically, it didn't talk about what happens to the back end of the vehicles. It only talks about what is happening inside the vehicle and how you should be securing it. So it says how you should have multiple shared responsibility between the OEMs and tier ones, and tier ones having shared responsibility of tier ones and tier twos. So all these things. So in whole manner, if we see, coming back to the previous slides of ours, so we see OEMs of particular embedded components. We see attacks happening on that wireless services. We see the shared responsibility and all. So imagine Jeep hack is happening right now instead of 2015. Classic example, because why I'm referring to Jeep once and again, because you have a lot of white papers and very detailed research which you can go back and check if you are more interested to know that, so that you can correlate the topics. So Jeep hack, let's see what happened. So they were able to attack through teleservices. If there is a thing, IVI, and if there is a shared responsibility between the teleservices and this thing, they too can coordinate and immediately close the attack. And next thing was like they were able to bypass IVI, and they were able to refresh the firmware after a lot of research, obviously, and they were able to use the SPI line between two components to talk with the canvas. So if they have evaluated this threat before, and the CIL level is 1 or 2 or 3, and it is very important, so they would have stopped it there itself. So proper checks have been not implemented, and there is no governing body to implement these checks. So that is one of the biggest problem. So all these things, you take whatever attack it is, if you are following a particular standard of 21434 and you are evaluating, at least you will know the posture of it. So future attacks, if we see, future attacks would be on EV charging stations, because a lot of electrical vehicles, common grid connectivity, and sometimes EV charging stations have top tier charging stations where you can plug in for software updates, also check for secure channels, check for software updates. Attacks on that can be happening. Backend servers already happening, and ECU or electronic units, telematics control unit, gateways, and what are the mobile apps. Even sometimes Benz and all, they have company made mobile apps to control your car, to know the status of the battery, to know what is the tire pressures and all. So how it is being communicated? Obviously, your phone is not connected to your car, right? So there's a particular channel the data is flowing. What is that? Evaluation of that also you have to make sure. And infotainment hubs, this is the future prospect. Now we have shifted from physical car hacking of tapping the bus and doing this thing to this way. So, and one thing I never like is a webinar without a practical demo. So we have talked about canvas, right? So if we remember, I'll just put back a slide. There are reply attacks, node spoofing and all. So we'll see how a reply attack and node spoofing will happen. I'll put on a IC simulator, which is a great tool for demonstration of these attacks. And I'll quickly switch to my VM where I can show you that. Just give me a minute. So I hope you can see my screen. If yes, can you put yes in the chat? You'll be able to see my Ubuntu. Yeah. Okay. So here it's a classic example of instrument cluster, the speedometer which you see in your vehicles, and there's a controller which is being used to here in this virtual setup which is being controlled the content. So I'm not going to do all these things, but I'll definitely be showing you how the reply attack works. So I'll be using can utils. So I installed can utils. It's my this is my lab VM. So I'll first do the indication. If I put a left arrow or right arrow, it will show the indication on the cluster. So what's happening in the backend is it is using CAN bus to pick up that signal and give it to the in IVI, in vehicle infotainment, to show a signal. It can be for brake also. It all depends. And for example, if we see an autonomous vehicle, there are some safety functionalities such a way that if your tire pressure monitoring system indicates there's a low pressure in the tires, and it can sometimes it can make the imbalance of the vehicle, so there'll be error warnings all happening. So how they are making it entirely depends upon the manufacturer itself. It's a vehicle. So we are in this webinar talking in a high level. So if you want to know more about how to evaluate short range, long range wireless attacks, what is CAN bus, and how to use this CAN utils and all. So I have already written blogs on our community website, which are open source for community. So you can refer that. I'll put the link in. I have already gave the link in resources. You will see it in the end slide. So you can learn more about CAN utils, how to use the efficient way, what is attack surface, what is automotive security, and CAN bus protocol, and what are the modern attacks and current. I have even did breakdown of 3 attacks, one on bench, one on T-bone attack, and Jeep attack. You can read all of them. So let's focus on spoofing. So I'll sniff first. CAN 0 is my network, and I put binary and coloring options to sniff the CAN bus. So if we see there's a lot of traffic going on. So for indication, if I do we might not be able to just pick it up because CAN has a very high bit rate. So it can literally dump thousands of messages per second, which we cannot do it from a human eye. So this is one way. Sometimes in assessments, I do this also to particularly see what part of 8 bytes are changing. If I know a particular ID, if I'm suspecting particular ID, arbitration ID, what part of 8 bytes is changing, or what part of 8 bytes is affecting the functionality of this. But in simple way, if we do, we can always dump the network into a file, and after that we can see it. So if I first start recording it, logging it, I'll give the right signal, and then I'll give the left signal, and then I also try to unlock all the doors. So now I'll stop recording and check if we have it. Yeah, I have the log. Let's close all the doors and let's play that back. So now we have no doors open and we don't have any indication lights available. But when we are playing it back, indication starts appearing, and also slowly the light will be showing up. So this is a classic example of reply attacks in a CAN bus. So doors are opening. So here, what are the assumption we are having is like in this virtual network, the doors, the indication lights are being controlled over CAN bus. So for your home takeaway home accesses, you can also control the speed which you can do it from your home. You can. There are a lot of tutorials available on internet to know more about this thing. So now also, if you see, the doors are not being closed. It has been only opened because we don't have the packets recorded which are responsible for closing the doors. I'll do it manually now. And if we see, I'll put the sniffer once again. And let's me control the speed. So basically what we have to do is we have to see which ID is changing when the speed is happening, when the speed is changing. So the data is changing, right? Some bytes will be changing. So we have to see which ID is changing in the sniffer or in the whole network. For this kind of things, I made a tool, but I'll do it now manually. You can use the tool also to filter the network. So yeah, the ID number 244 is changing. So I'll now show you how you can, do packet injection to trigger some particular thing. In bytes, and I'll close this so that it won't bring it back. And let's hope I'm correct. Yeah, see, the speed is literally changed to the maximum level happening. So these kind of attacks are possible on canvas. So this is the very crispy part of it. But yeah, so imagine you're getting, stop sharing, and let me share my presentation. So imagine you are able to get into backend servers which can inject packets on canvas. You are able to get into TCU which can inject backend on canvas, central gateway on canvas, and mobile apps which can control central functionalities like closing the door, opening the door, and all these things. Infotainment hubs which can switch off, switch on lights while you're traveling in a highway network, in like 60, 70 kilometers per hour. What do you think it will be happening for you when somebody is playing with your lights? So all this is possible, and that's how we should think about automotive security as an attacker. Whatever it is we can control. How can we control all the functionalities which the car is being used? How can we tamper them? How can we attack them? Everything we have to think. So few resources and references. I obviously referenced to 1434 of official documentation from SAE and ISO, and blogs on automotive security by Payatu. You can check out Payatu wall page, or you can click on the link. You'll get it. The thing once you receive the PDF of this presentation. Car Hackers Handbook, which is a very, I would say, it's a starting for any person who wants to know into car hacking. I think it's open source now, and there is hacking connected cars, tactics, techniques, and procedures. It will teach you different methods on how to evaluate V2V attacks or V2X. And Car Hacking Village, they conduct villages in Black Hat, DEFCON, and many in partnership with a lot of conferences. There's a lot of information and a lot of top-notch research is being presented there. ASRG is such group where they will also set up labs and everything in European countries and American countries. But in India also there are a lot of chapters. There are chapters in Kerala, Bangalore, Hyderabad. I think in Mumbai also there's a chapter coming up in Delhi, Mumbai and Delhi. I'm not sure. So all these things, they are giving resources to learn more about this information. So at the end, I would like to say, if you are from AppSec, you are interested in automotive, you're already into automotive. In fact, if you are from hardware security, you're already into automotive. If you're an IoT, vehicle is an IoT right now, so there's no need of explanation. So it doesn't matter which field you were, what expertise you have. If your expertise in cloud services or cloud attacks or firewall design or everything, whatever it is. So now automotive is came into a where everybody is supposed to be doing. So it's a both side. You have an employment opportunity here, you have an research opportunities here, and also companies are looking for multi-diverse companies which can provide cybersecurity and assessment solutions for them. So if you want to jump in, there are a lot of resources. If you want to know more, there are a lot of talks available. You want to know more about certain topics in depth, which we talked in this webinar. There's blogs. So don't just wait. Just let's get started and let's make it community. And yeah, that would be all from my side. And if you have any questions, please let me know. So if I can answer, I will definitely answer. Yes, you get the presentation after this. I think you'll also get the recorded session on LinkedIn page of Payatu. Make sure you follow Payatu. Connected cars, there are a lot of connected cars, Mr. Amit sir. Yeah, XUV 100, 300 is there, 700 is there, Mahindra is there. Any car, if you see in vehicle infotainment system and it can download updates, Basically, it's a connected car. It's not only connected car. Nowadays, it's connected vehicles, also electric vehicles like Ether, Ola, and other things. If it has a capability of communicating with backend servers, then it's a connected. So can we try new two-wheeler vehicles with the same system? So I assume that when you say same system, the approach, yes, it's the same approach. Yeah, if there is a canvas in that electric vehicle, I agree there are canvas in electric vehicles nowadays. Yeah, you can try those attacks, all this speed possible, indication signal spoofing, everything, packet injection is possible. And yeah, you can use the same approach to evaluate electric two-wheeler vehicles also. Like the one that you showed in your demo, I couldn't understand what do you mean by like the one you showed in the demo. If you have a question, can you rephrase it?
No, I mean there are two. Sorry, this is Arun from Vector.
Hey,
before the previous comment about the EV2, there was one more question that I asked regarding how do you solve these replay attacks in the automotive industry, or are there any
so yeah,
standards?
replay attacks. So first thing is like if we will be able to do a replay attacks only because we are getting access to that. So breaking down an entire car, if we're gonna sit and discuss more about like can we make sure that nobody can get access to the canvas, it's not possible. So one way we can do check for the replay attacks is like there is always whenever the message flows in a particular bus, there's a certain amount of bandwidth is being used. So if we can track the frequency of that particular ID, for example, if there's a indication ID, it is designed in a way that you have to update yourself in 1/10 of a second every time, every 1/10 of a second. But now in a replay attack, it is abnormally changing its timeline or it's using abnormal bandwidth. Then we can detect that using an intrusion detection systems, which the companies can definitely develop integrated with the other OEMs and the technicians. And using those kind of measures, we can detect, and based upon that, we can engage a kill switch if we identify anything is possible or not. That is a whole new topic. But I believe using this kind of techniques, we can detect and take necessary actions. And I'm very sorry, Arun, I missed your first question.
No problem. I was more thinking, I'm not sure. Have you heard of secured onboard communication? SecOC, is this anything that solves these replay attacks by any chance? Or no, maybe. Yeah, we can just ignore it otherwise. I mean, I'm just curious.
If it is a solution, please let me know. I'll love to read more about that.
Yeah, I mean, I just heard there is an AutoSOR specification. AutoSOR is, automotive standard. There's something called secured onboard communication, which try to address these replay attacks. So just curious if you know more information about
it. Unfortunately, I don't know the exact mechanism which you're talking, but if you have any resources available, please put it to me and I would love to know more about it.
Yeah, sure. Yeah,
Thank you. And which security products are currently being used in automotive industry? Mr. Amit sir, what do you mean by security products? Like the vendor-based tools or ECUs and all?
Kartheek,
yes, sir.
Security products, anything which will help you to secure the existing connected car infrastructure from the defense point of view. Then any anomaly detection type of products on the other point of view. So secure what you have, find out anomalies, and from that point of view.
So IDS and IPS, intrusion detection and prevention systems, I never saw any product in the market right now in 2022. I'm talking this day, which is very much effective and all, because there's a lot of work which have to do. Maybe in the future, 2-3 years, we can see those kind of things. And for assessments, we have to go with the same threat assessments and penetration testing for the cloud servers, penetration testing, IoT pen testing and all, which Payatu provides those services. So anybody can definitely utilize them where we give you an overall thing. And other things, if we say like, tampering the canvas and all, those kind of services are also available. There is only assessment services. There are no products right now in market which can effectively defend against those attacks. It's all like a pre-attack and post. There's no things I'm aware that which can actively defend the whole thing.
Okay. And Karthik, what about encryption? I mean, what kind of are encryption techniques being used in the connected car hacking from any?
Yes, there is encryption
Uh,
being used between external communications. There's definitely that is definitely there. But if you talk about encryption over canvas, it is not quite feasible because canvas messages are very time restrict and time reliant. So every message should go first. We cannot wait for a microprocessor or a microcontroller to calculate a hash or assign a private key and then send it. So it is not based right now in vehicle companies are not moving forward because the protocol itself has a constraint. But there is one particular protocol which has been recently developed on CAN HG, where it's from Canis Labs. It's from the person named Ken Tyndall. So he claims that we can implement security also. But I would really love to see the industrial application and reply attack on that, because if even the packet is hashed, if you are going to send the same packet once again without any intrusion detection systems or IPS, then it is very much possible to spoof that action once again.
okay, okay.
Thank you, Christian.
Karthik,
Yes,
Ashwati has raised
yes, please.
hand.
I'm just reading the questions. Yeah. Hello.
Ashwati, if you have a doubt, you can put it in the chat box as you have raised your hand. So,
Push for right to repair which would make things worse for security, open sourcing everything to all paper repair shops and therefore bad actors. Yes, Christian, it's a right to repair is a double-edged sword. If you're thinking like an attacker, then definitely you have now in private rights to repair that and all. But I don't see it in that way. There are, if we see at open source softwares and open source tools and communities, they're more towards engaging more of their personal time in securing the products which being used on internet. So I would see it as like more flexibility to do conduct research on their own. So I'm a white hat, so yeah, I would definitely love to see right to repair in India also. Do we have any particular list of tools or hardware tools that are based available in open source for this kind of attacks? Software tools, yes, can utils, you can always do things, but hardware tools, I don't think there's any particular open source tools. You will get the Java files and the PCB layouts and everything. You can make your own tool based upon that, but I don't know any tool except from one tool. This is called NanoCAN, which is based on MCP2515 transceiver CAN transceiver, and in Arduino Nano. You can use it. I'll put it in the chat. It's called NanoCAN. You can use it to an Arduino IDE to basically tap the canvas, but it is very constant because it is particular to one particular protocol. So that would be for open source. And for this kind of attacks, if you mean by in-vehicle canvas attacks, that depends upon you what you want to do, spoofing or replay injection and all. But if you're talking about wireless attacks, then there are a lot of tools. As I said, like if you're from AppSec, you know better than me. If you're from web security, then you know better than me. If you're cloud, particularly cloud. So I'm basically IoT security researcher. From hardware side, yeah, I know. There's exploitive framework for these things, and you can get an exploitive kit also. Aparna, can we have the exploitive store link here?
sure.
So you can use that for IoT or electronic components and embedded components evaluation and all those things. There's an IoT auditor which we are coming up with a new product which is in beta phase right now. You can always keep a look on that. It will help more of your firmware evaluation and all. So any automotive vulnerability cheat sheet, what are they in automobile? So Neeraj, I believe you are there from start of this thing. So when we say automotive, it is not constrained to anything. You cannot make a cheat sheet of it because every company, every model is different. Whatever, if you even change one ECU, its entire architecture will be different and threat levels will be different. So there is no cheat sheet. What you will be doing is like automotive assessment, security assessment is something like a diversified assessment in your organization itself, where 2-3 expertise teams will come together to assess one product. So I don't think where we can make a cheat sheet for this. You can have a checklist, by the way. You can definitely have a checklist. If you look at the connected cars hacking book, they have a example checklist where you can make an Excel sheet of what components being used, what should be attacked. That will help you a lot in that case. As an automotive security researcher, what is your opinion on systems like Open Pilot by AI? I'm not here to comment on anything, Vishal. We can have a discussion outside of or engaging activities. And is it possible to add sequence number in packets in order to avoid replay attacks? See, now you're talking about changing the protocol functions itself. Then the idea, we have to think like a developers and car companies. Adding a sequence number in that, it is possible. But what if I take a sequence of packets and play it in the same order? Now, if you say, no, that is in a particular hash and it is being generated, how are we going to make sure that we are not getting any delays in generating the packets and all? So we have not only solution, we have to see the feasibility of the solution. It is possible, but how and what bandwidth and what are the things which you're going like willing to let it go, it depends on that. But it's a nice question. Yeah, here's our exploit to store link, and I think one person, Ashwati, if you're still in the chat, please ask your question. AutoSor SW secure onboard communications. Okay. Thank you, Arun.
I just added because I just Googled it now.
No worries.
And there seems to be the secured onboard communication, which actually solves the problems that you just mentioned in the replay attacks by having some freshness values and so on. I mean, there are details, but you can look into it.
Yeah. Thank you for sharing. And I hope automotive companies will use the standard and it gets regulated and everybody has to, use this.
Yeah.
Are there any more doubts from the participants? So, thank you all for participating in this webinar. I would like to thank Kartheek for delivering such an amazing webinar on automotive security. I hope you found value in all his deliverabilities. So let's conclude this webinar now.
Thank you guys. Thank you, Aparna, for handling the webinar, and thank you guys for attending my webinar. If you have any doubts, please don't hesitate to hit me up on LinkedIn or Twitter. We can chat there also. Thank you. Have a nice weekend.